Hi, we are going to do the chapter fluids. You take a rubber ball, 4 or 5 places at a distant place, you put a hole through a compass. You inject water throughout the rubber ball. When you press it, the water will come out equally from all the holes that you have done. While washing or they want to do some repair at the bottom of the under of the car, what they will do? Center stem will come, through that one the car will be rested. Then on the other side, they will roll it. So you take a stone of appreciable size, put the stone in the water. Will the stone float? You take a wooden piece and put it in water. The wooden piece will float. You take water, over to that you apply or you pour kerosene. Completely shake it. After some time, you can see there, kerosene will be at the top. When the bucket is fully immersed inside the water, you can feel in the rope that there is some weight loss, as if the bucket has gone. Bucket வந்து கையை விட்டு போன மாதிரி ஐயோ பக்கெட் போயிடுத்தோம் சொல்லி டக்குன்னு இழுத்து பார்ப்போம், அப்ப தண்ணியோட பக்கெட் மேல வரும். When you immerse a stone, how much of water coming out, you calculate. Find the mass of this water using physical balance. Very simple. In the basic chapter, fluids chapter. Importantly, we are going to talk about liquid pressure here. Generally, what is called pressure? Pressure is force by area. This is mechanical pressure. In the case of liquids, we call this as thrust by area. Thrust by area, we call it as pressure. Thrust is nothing but force. In the case of liquids, we will use the term, that's all. In the case of liquids, we will use the term thrust. Fine. So, fluid pressure is equal to total force exerted divided by the area under which the force is applied. Which area you are applying your force? That area. So I can write pressure is equal to F by A. Say for example, you are considering a beaker of water, and here you have an opening. The height from the top is h. So the pressure of the liquid which is coming out, the pressure which is coming out here is force. That is nothing but the weight of the liquid which is coming out. mg is the weight, and the area applied here is A. So pressure is equal to force by area, mg by A. But what is volume? Volume into density is called mass. Volume of the liquid here, this portion. So that volume into the density, we call it as mass, into G by A. So I can write pressure is equal to, what is volume? Volume is area into height, into rho, into G by A. A cancel. So I can write pressure is equal to H rho G. So H rho G is the pressure exerted by the liquids. If it is at a certain height, so hereafter liquid pressure means you can talk only H rho g. Pascal's law. Pascal's law. When a pressure is applied to a substance, the pressure is distributed equally among its entire area. That is called Pascal's law. Suppose you have a glass container having some holes here. You are stopping that holes or you are fixing that hole through something. Now you are applying a pressure from the top. Some liquid is here, say water. You are applying a pressure. You remove all the corners, all the four sides. When you push the piston downwards, the liquid is coming out equally in all directions. The amount of liquid coming out through this end is same at all the four places. Any number of places you have, the pressure exerted by the liquid is same. You can take a normal example, ma'am. You take a rubber ball, 4 or 5 places at a distant place, you put a hole through a compass. You inject water throughout the rubber ball. When you press it, the water will come out equally from all the holes that you have done. Equally, the water will come out. So that is called Pascal's law. Okay. We have many applications of Pascal's law. Hydraulic brake, hydraulic press, all these things. Hydraulic lift also you can use. Hydraulic lift means suppose the body has got so much weight. The mass of the body is enormously high. You cannot calculate the mass with normal weighing machine. So what they are doing? Hydraulic lift. U-tube of different cross-sectional area. This is called the reference point or reference line you take. The body whose mass or weight to be calculated. You keep it here, keep one plank, over that you are keeping the body. And here you are applying a force through a piston. Area at this point is A1, area at this point is A2. Because different area of cross section. Tube of different cross sectional area only you have taken. So when you compress this side, the water level here goes down. Same water level here raised up. So by Pascal's law, the pressure exerted on both the sides are equal. Previously, it is at equal level. This reference line. After applying the force, only it has been shifted. So by Pascal's law, force at the point this side on the right hand side and the force on the left, pressure exerted on the left hand side. Force by area, that is pressure exerted on the right, force by area, pressure exerted on the left is same by Pascal's law. So I can write F1 by A1 is equal to F2 by A2. So F2 is equal to F1 by A1 into A2. Simple. You can calculate the diameter on both the sides. So you can write pi r square, r2 square, pi r1 square. The force is nothing but the weight what you are pushing down. So that you can calculate the weight of the object. It is not the mass you are calculating, it is the weight you are calculating. Divide by G will give you the mass. So this is hydraulic lift. Actually, this is used only for lifting the particular object which is of higher loads. Car wash and all you might have seen in the car garage. While washing or they want to do some repair at the bottom of the under of the car. What they will do? Center stem will come, through that one the car will be rested. Then on the other side, they will roll it. So the car is slightly lifted. Lifted means they can go down and see whatever problem under the car, or they can wash it. So that is the principle of hydraulic lift based on Pascal's law. Clear? Simple concept. Next, relative density. Density of particular substance by density of water at 4 degrees Celsius. Generally, any formula if you take regarding relative density, everybody will say that density of substance by density of water only. It is correct. But why density of water at 4 degrees Celsius we have to calculate? Density of water is maximum at 4 degrees Celsius. 1 gram per centimeter cube at 4 degrees Celsius, water density is 1 gram per centimeter cube. So the relative density value will be high. When denominator is low, total value will be high. That is the meaning. Accurate calculation, density of water at 4 degrees Celsius we are doing. Okay. Floating and sinking. Simple concept. When the body will float on water, when the body will sink. You take a stone of appreciable size, put the stone in the water. Will the stone float? No, medakkumada, medakkaadu. Ulla muliginu. You take a wooden piece and put it in water. The wooden piece will float. There is a difference. What difference? In the case of stone, the density of stone is greater than the density of water. Density of stone is greater than density of water. So it is sinking. It has gone inside. But density of wood, the wood piece, what you are taking is less than the density of water, so it is floating. You can see another tool, sir. Can I take 2 liquids, sir? You take 2 liquids, no problem. You take water and kerosene. We should not mix water in kerosene, sir. That and all general. But now experiment I am talking. You take water, over to that you apply or you pour kerosene. Completely shake it. After some time, you can see there, kerosene will be at the top, water will be at the bottom. Because density of kerosene is less compared to the density of water. So kerosene is floating. It is not floating, it is upwards. Water having higher density at the lowest point. Density of kerosene is less than that of water, so it is at the top. So this is the concept of relative density. No unit, numerated unit is kilogram per meter cube, denominator unit is kilogram per meter cube. So relative density is a number, no unit. Clear, Amma? Hydrometer, lactometer, this and all you can use for discussion in the case of measurement. To test the purity of the milk, we are using lactometer. Basic examples. Okay. Fine. What is called buoyancy? You might have heard the word buoyancy or buoyant force. It is an upthrust of the liquid, upward force experienced by the liquid. When a solid is fully or partly immersed in the liquid, there exists a difference in force between top and bottom. Bottom, it exists more force. Top, there exists a less force. Because bottom pressure is more, top pressure is less. So force is more at the bottom, force is less at the top. This difference in force will act in the upward direction. That is called upthrust force or buoyant force. And the concept is known as buoyancy. Any solid moving in the liquid. Maybe in the second part we will discuss about viscosity and viscous force and all. That time in detail we will do. The solid is experiencing a downward force, mg, that is called weight. Say for example, this is a liquid. One solid is moving inside the liquid. This is a solid. Two forces existing in the case of solid. One is called the weight acting downwards, mg. Another is called upthrust or buoyant force acting upwards. This is force of buoyancy. Acting upwards. Correct, Amma? So simple concept. An all-time famous question, Archimedes Principle. What is called Archimedes Principle? Before that, some basic concept we should know. Suppose you are drawing a bucket of water from the well. When the bucket is fully immersed inside the water, you can feel in the rope that there is some weight loss, as if the bucket has gone. Bucket வந்து கையை விட்டு போன மாதிரி ஐயோ பக்கெட் போயிடுத்தோன்னு சொல்லி டக்குன்னு இழுத்து பார்ப்போம், அப்ப தண்ணியோட பக்கெட் மேல வரும். அப்ப that is called apparent loss of weight. It is not the actual loss. It is called apparent loss of weight. So the apparent loss of weight of the liquid is equal to weight of the liquid which is displaced. This is the law of flotation that is called Archimedes Principle. I don't understand, sir. How to calculate? Actually, how to calculate this apparent loss? Mass into G is called weight. So if you know the mass, you can calculate the weight easily. So apparent loss of weight means calculate the apparent loss of mass into G will give you the weight. Simple concept. So laws of flotation, basic concept based on your Archimedes principle. That is apparent loss of weight is equal to actual weight minus weight of the liquid displaced. How to calculate, sir? Sir, you take one small stone, calculate the mass of the stone. Okay. Mass of the stone, you take it as M1. Mass of solid. You take beaker of water, find the mass of the beaker with water. M2. Mass of water in beaker. Using physical balance only, you are calculating the mass. The object, the water with the beaker on the left pan, right hand side pan, you are adding the mass. At one time, these two will be equal. So you can calculate the mass of the beaker with water. Now, you just keep the stone, tie the stone with a thread, hang it. Just it immerse in water. Just it is immersed in water. How much height it has raised? How much height it has raised? You find out. That is called the volume of the liquid. That volume into density will give you the mass of the liquid displaced. At that moment, what is the mass you calculate? In the physical balance, at that moment, what is the mass you calculate? The difference in mass, original mass of the stone you have calculated, when it is immersed inside you have calculated, the difference in mass will give you the mass of the liquid displaced. Simple. Another experiment. Sir, this physical balance, I don't know. Simple experiment you tell. Physical balance itself is simple only. Okay. Suppose you have a beaker. Here we have one opening. Now, you immerse one stone inside and how much amount of water coming out? When you immerse a stone, how much of water coming out you calculate? Find the mass of this water using physical balance. Mass of the stone before inserting in the water, mass of the stone after inserting in water, you calculate. The difference in mass, we call it as apparent mass. That is equal to apparent loss. It is not equal. Both cannot be equal because when it is immersed, the mass is found to be less. That difference in mass, we call it as apparent loss of weight, apparent loss of mass of the stone in the water. That is equal to mass of the liquid collected. Weight only I want to calculate, sir. No problem. Calculate the apparent mass. multiply by G, you will get the apparent weight. Correct, Amma? So this is Archimedes principle, basic concepts. So we have seen only the basic concept in this chapter, fluids. Second part of the fluid, we are going to talk completely about viscosity of the liquid. What is called the surface tension? What is called streamlined motion and turbulent motion? What is called equation of continuity? An all-time famous question, what is called Bernoulli's theorem? So these topics we will cover in fluids second part. Okay, Amma. Thank you. We'll continue.